Hello everyone and welcome to the channel. In this video, we will be using neural networks to classify customers as either buyers or non-buyers. We will be using a dataset of 5,000 customers to train our neural network. The dataset includes information about our customers like gender, age, number of children, income, province, and so on. Then we will use the trained neural network to classify 2,500 new customers to tell us how likely they are to be a potential buyers. The benefit of this project is to optimize the marketing budget by targeting the right audience. So let's go ahead and do this in Python.
We need to import some libraries. So we need pandas to work with data frames. We need TensorFlow to build the neural network. And also from sklearn model selection, we need the trend test split. This is to split our data. And also from sklearn pre-processing, we need the standard scaler. This is to normalize our data. And finally, also from sklearn metrics, we need the accuracy score. This is to evaluate our model. Let's run this. And now let's load our data into a pandas data frame. And let's take a look at our data. So as you can see, we have a unique ID for each customer. We have first name, last name, the gender. If the person is female, is 1. If a male is 0. If the person is married, it will be 1. If not, is 0. The age, the income, number of children, the province, and if the customer has bought the service or the product or not. And the data is for 5,000 customers. Now let's take a look at the data type in each column in order to do some data preparation before we move on and start training our model. So customers.datatypes will give me the data type in each column. So remember that machine learning algorithms work with only numeric data. So we have the ID column here is already numeric data. We have the first name and the last name are having object data type, which is here. But since we already have a unique ID for each customer, so we don't really need these two columns. And then we have the rest of the columns are having a numeric data, except the last two, the province and the boat, which is this one and this one. So we will need to convert these two into a numeric data before we continue. So let's do this here. So from our data frame customers, the province column will be replaced by a new column with the same name, but with the numeric data type using the .cat.codes. Similarly, for the boat column, is going to be replaced by a column with the same name, but with a numeric data type. And then we want to create two new data frames from our original data frame. X is going to be our input. So that's all the columns except the last one, which is the output or the label. And Y is going to be that column, the output or the label. So X is going to be all the columns in customers except the both column and the first name and last name. We said we will just drop them because we have already a unique ID for each customer. And the Y data frame will be including one column, which is the last one, which is the output. So X is the input, all the variables, Y is the output, which is the label, if the customer has bought this service or this product or not. So let's go ahead and run this. And if we take a look at X, we can see that it is now all the columns, including the province, has been converted into a numeric data. And if we look at Y, also converted into a numeric 0 and 1 if the customer bought the service of the product, or the products will be 1, if not, will be 0. Now let's split our data into a training dataset and testing dataset using the train test split from sklearn. So both X and Y will be splitted into a training dataset and testing dataset with the ratio of 30%. So 30% is going to be for testing and 70% for training. Then we need to normalize our data using the standard scaler from sklearn. What do we mean by normalization? Is basically a type of transformation so that the data to have a mean of 0 and a standard deviation of 1. Why we are doing this? Because machine learning algorithms work well and work better if the data is having only one scale. So let's go ahead and do this, and we can take a look at our X train scaled. So you can see that all the data is now having one scale in order to have a mean of 0 and a standard deviation of 1. Now, since we have our data ready, let's go ahead and build our neural network. So using TensorFlow Keras sequential. So sequential is basically that the layers will be connected in a linear way. We will build three layers, one input layer, one hidden layer, and one output layer. The type of layer is dense, which means that it's fully connected. So all neurons from one layer are connected to all neurons in the next layer. So our first layer is the input layer with 64 neurons. The type of activation function is reloop. If you don't know what is activation functions, I will try to leave some material in the description of this video to explain the different type of activation functions. And then the input shape is basically our input data, the extrain scaled shape. So the number of features that we have in our input data, which is basically 7 columns, 7 features. So this is the input layer. Then one hidden layer with 32 neurons, and the activation function is reloop. And lastly, one output layer with only one neuron because it's a classification function, and the activation function is sigmoid. Once we have built our neural network, then we need to do some configuration for the training process. So the loss is basically the method that the model is using to evaluate or to calculate the difference between the actual value and the predicted value. So the method here is binary cross entropy, which is commonly used with classification problems. The optimizer is Adam, one of the commonly used optimizers as well, which is basically the method or the way that the model is trying to reduce the difference between the actual and predicted. And the metrics is the accuracy is also the way that the model is evaluating the performance and trying to reduce the difference between the actual and the predictions. And once we have configured all this, we are ready to train our model. So we pass the data, the input data, the X-train scaled, the label, the output data, the Y-train, and we have to specify the epochs, which is basically the number of iterations, how many times the model will go through the entire data set. We will keep it for 10 for now, and we can change if we want to improve the performance of the model. And the batch size is the number of samples that the model is processing at once before updating the weights of the neurons. And lastly, the validation split is that 10% of this data will be used by the model to monitor the performance of the model. So if we go ahead and run this, you can see that we have 1 out of 10 epochs. So the model has gone 10 times through the entire data set and started with this with 0.5 accuracy, and then the last at the last epoch the accuracy was almost 0.67. Now, since we have successfully trained our model, our neural network using the training data set, let's go ahead and try to use the testing data set to make some classification or predictions and to see how good is the model. Now we have already done some classification or some predictions. If we take a look at the output, you can see that it is between 0 and 1, which is a probability for these customers to be a buyer or non-buyer, or if they bought this service or not. If we want to convert this into 0 or 1, we can just say that if the probability is more than 0.5, is 1. If it is less, then it's a 0. And then we calculate the accuracy between the actual output of the test dataset and the predictions, which is 0 and 1. Because in our original data, the y-test is also 0 and 1. It's not in the probability form. If we run this, the accuracy is 0.68. Let's also take a look at the confusion matrix to further understand the performance of the model. So from sklearn, we import confusion matrix, we pass the y-test and y-predicted binary after being converted into 0 and 1 here, and then we calculate the confusion matrix. So we can see here from the confusion matrix that for the customers who did not buy this service or this product, the model has correctly classified them 678 times, while 205 times the model classified them as if they bought the service or the product, but in fact they did not. For the customers who actually bought the service or the product, the model has correctly classified them 343 times and misclassified them as if they did not buy this service or product 274 times. So we can see that the model is doing well with classifying people who did not buy this product or service, but not really good in classifying the people who actually bought the service or the product. For this specific type of classification problems, this performance and this model is not bad and can still be useful. Imagine if you have 60% confidence that this customer is probably to buy your service or not to buy your service, then you can efficiently utilize your marketing budget, and you can utilize your resources in an efficient way by targeting people based on the insights from this model. And it's still better than having nothing and just targeting everyone and wasting some resources and some money in the wrong place. Now, finally, let's use our model to classify new customers that we don't know if they will buy this specific service or specific product or not. So let's import the data set for new customers. As you can see, we have the same data set, except that we don't have the both column because we don't know this is new customers. We don't know if they will buy our service or not. So we will do the same preparation before we do predictions. So we need to convert the province column into a numeric data, and we will need to drop the first and last name columns. So we do this. So this is our data now. So we will pass this data to the model, and we'll try to classify these customers. And if you notice here, the ID of the customers starts from 5001 because our data was for 5,000 customers that we know that they already bought our service. And now we have 2,500 new customers that we don't know if they will buy our service or not. And we will try to ask the model to classify them if they are potential buyers or not. So we have the data prepared. We pass it now. We normalize it like we did for the training data. And then we pass it to the model and try to do some classification. And then finally to print or to show us the buying probability for these customers. So if we do this, now you can see that we have a new column that is the probability for each customer if this customer is likely to buy our service or our product or not. And that's it. Thank you very much.